Yeah, I have pasted the live streaming link in the chat box as well as in the calendar. So in the last week, uh, we are in the week 7 and now we are in the week 8 now of live session 1 in signals and system. So in the previous week, a 4 year series and of about 4 year coefficients properties of 4 year series, they are explained and discussed in detail, and some of the problems were being also solved. And I'll be discussing about important topics. Those are Parseval's theorem and Dirichlet's conditions, as well as along with that 4 year series in LTI system will be discussed. So, coming to the Parseval's theorem, uh, I would like to give an analogy over here for Parseval's theorem. So, if you take an Indian rupee and American US dollar, so if we want to compare between those two things, they are both are money, right? Rupee and dollar, but we want to have some relation between them. So, in similar way, in Fourier series will be making us to know the what are the harmonics present in the signal. So it helps us to convert the periodic signal from time domain to frequency domain. So we want to have the relation between time domain as well as the frequency domain, right? So this Parseval's theorem helps us to relate the energy of the signal, or it could be energy or it could be power of a signal in time domain and in the frequency domain. Are you getting me? Yeah. So energy, can anyone tell me what is the formula for energy? So energy formula is integral minus infinity to plus infinity modulus of x of t whole square dt, right? So this is in the time domain. In the frequency domain, the same energy can be represented as 1 by 2 pi integral of minus infinity to plus infinity modulus of x of w whole square dw. So here W is fundamental frequency. So W will be 2 pi by T. Uh, and so this Fourier series is for one note I would like to tell is Fourier series is for periodic signals. So like for the periodic signals, we will be having the energy as infinite. So we will be considering the power. So this helps to relate the power of the signal in time domain. So which will be equal to sum of squared magnitudes of Fourier coefficients in the frequency domain. So we have known if the signal z of t for the Fourier series, it could be expressed as sigma k is equal to minus infinity to plus infinity a k e power j omega kt, right? And where ak is 1 by t integral of in the interval of t z of t e power minus j omega kt dt. So, power, like, what is, can anyone tell me the relation between energy and power? Can anyone respond?
Average of energy called power.
I am telling, like, what is the relation between energy and power? Energy and power. What is the relation? So power is a average of energy, right? In time. So power can be represented as energy by time. Am I right? Okay. So power is equal to 1 by T. This is the energy which is taken in the time interval of that periodic signal from minus T by 2 to plus T by 2 modulus of x of t whole square dt. So this is in the time domain, which could be expressed in frequency domain as sigma k is equal to minus infinity to plus infinity modulus of ak whole square. So where ak is this, or like this is x of t. Am I clear? This slide. Can I go to the next slide? So, like, we have come to this Fourier series because, like, from the convolution, right? Like, a convolution takes lot of computation now. So, that's why we have jumped from convolution to Fourier series. That's the reason we have, in order to reduce the computational time, we are going to Fourier series. So, for the LTI system, if we give x of t as input and h of t is this impulse response, then y of t can be expressed as x of t convolved with h of t. So, uh, or like now here input signal is taken as z of t. So, it will be z of t over here. Uh, One note is that when we send the uh, complex sinusoidal signal or phasors for the into the system, into the LTI system specifically speaking, we'll be getting the eigenvalue or eigenfunction form, right? Means if we send the e power j omega t into the system, then we will be having some lambda times of e power j omega t. So it is a phasors or the eigenfunction. So, like, in the previous slides, I have discussed about this formula. Like, this is a relationship between uh, uh, Fourier. This is a Fourier series formula, and when we send this, we'll be getting in this way. So, when we send the signal z of t, then how the uh, it will be? Let's see, z of t convolved with h of t will be equal to sigma k is equal to minus infinity to infinity ak e power jk omega t convolved with h of t. As it is LTI system, it can be it follows a linearity and time invariant system. So it can be written as sigma k is equal to minus infinity to infinity ak e power j k omega t convolved with h of t. So like h of t convolved with e power j omega t is equal to, as it is eigenfunction, it will be lambda omega e power j omega t, right? So this can be written as sigma k is equal to minus infinity to plus infinity ak, as here is over here, we will be including uh, along with omega k as well. So it will be, so it will be omega k omega e power j k omega t. So what is added over here? So this is the output pi of t. So uh, if we send the periodic signal into the LTI system, we'll be getting the periodic signal only here. So if it is periodic, this will be also periodic. And let's assume y of t can be expressed as sigma k is equal to minus infinity to plus infinity bk e power jk omega t. So this is a, after convolving we are getting this, right? This is the output. So once we compare these two, so bk is equal to ak times lambda k omega. So from this we can make it bit we can reduce the computation as well from this formula. And one more thing is, if ak so uh, so bandwidth for this will be less than or equal to uh, bandwidth of the output. Bandwidth of the output will be less than or equal to bandwidth of the input. This point you have to remember, because this is a Fourier coefficient, Fourier series coefficient, and this is lambda k, which is a constant. Bandwidth in the uh, bandwidth. So if this is 0, so bandwidth in this also get tends to be 0. That's why it is less than or equal to over here. Am I clear? Hello, sorry for the interruption. Am I audible now?
Yes, ma'am.
Okay. There is a network issue. So, until here, am I clear?
Yes, ma'am.
Okay. So, one more thing over here is, uh, I would like to discuss about impulse train. So, impulse train can be represent as. Can anyone tell how what will be the formula for impulse train? So, I'll be drawing the uh, signal. So this is how impulse train looks like. 0, t, 2t, 3t, minus t, minus 2t. So they are separated by interval of t. Can anyone tell me how mathematical expression for this? Okay. It will be expressed as they are the shifted versions of delta, right? So a delta of t minus n t. So where n will be from minus infinity to plus infinity. This is how impulse train will be represented. So what's the question over here? We have to find the Fourier series. So Fourier series formula is z of t is equal to sigma k is equal to minus infinity to plus infinity ak e power jk omega t. So where k is the integer and omega will be represented as 2 pi by t. So here ak is 1 by t times of in the duration of in the time interval of t. So I'll be assuming from uh, minus t by 2 to t by 2 z of t e power minus jk omega t dt. So I'm considering in this interval from minus t by 2 to plus t by 2. So this can be represented as it is delta. So we are having only at 0. So we will be considering. So uh, except at uh, uh, time t is equal to 0, delta of t will be infinite, right? Other than this, else it will be 0. Delta will be 0 in this time duration from minus t by 2 to t by 2. So we will be writing it as ak is equal to by substituting t of 0, it will be, and z of t will be like we will be considering it as unit delta. So it will be 1 into e power minus jk omega into 0. So e power 0, so this will be turning into 0, e power 0 will be 1. So ak will be 1 by t. So z of t will be sigma k is equal to minus infinity to infinity. We'll be substituting this in this formula. So it will be 1 by t e power jk omega t. So now I want to express in terms of omega. So from this we can write, we will be substituting over here. So it will be sigma k is equal to minus infinity to infinity. So it will be 2, uh, what to say, omega by 2 pi. Omega by 2 pi e power jk omega t. Am I clear till here? Hello. Am I audible now?
Yes, ma'am, you are audible.
Am I clear till here?
Yes, yes,
Or
ma'am.
you have any doubts? Okay. So now I would like to. So we have discussed about the impulse train, right? Now we'll take the rectangular signal. So it is a finite, but Fourier series is for periodic signals. So it is not a periodic signal. So I want to make this triangular rectangular signal into train of rectangular signals. So how can we convert from this to uh, train of rectangular signal? So this can be converted into train of signals by convolving this with, when we convolve this rectangular signals, we'll assume this as x of t. When we'll be convolving with the train of impulse signals, we'll be getting like this. So how this is possible is, so this can be, as it is LTA system, it can be following the linearity as well as time invariance. So it can be written like this. And we would have learned the properties, right? Properties in convolution. When we convolve this with some delay, what will be the result from the shifting property? So it will be like x of t of delta t minus nt will be x of t minus nt, right? So from here it will be sigma n is equal to minus infinity to infinity x of t minus nt. So this will be the impulse train with the, it can be converted like this. So they are separated with the interval time t, and so here it will be minus t by 2 to t by 2 will consider like in this duration. In this way it can be converted like this. Can I move to the next slide?
Yes, ma'am.
Okay. So Dirichlet's condition. This is these conditions are very important. Why? Because uh, it tells the convergence, like is Fourier series is applicable for all the periodic signals. Like I was telling, Fourier series is for periodic signals, right? So is this applicable to all or not? That's the question. So in some cases it is not applicable in for the periodic signal as well. So in order to follow this Fourier series, uh, we have some conditions over here. There are three conditions. First condition is z of t need to be absolutely integrable. So z of t need to be integrable in time, absolutely. And it should be finite. This is the first condition. And the second condition is it should have finite number of maxima and minima. So let's consider the signal, which is there is, and later again it will be like same pattern will be repeating. So it is, there should be finite. It will be these are going. I will write. There should be like here it will be continuing in infinite number of times. So I mean consider the example. In this case, we are not having finite number of maxima and minima. So in between this duration also there will be many things going like this. So they should, if it has only finite number of maxima and minima, then it satisfies it for, we'll be getting the Fourier series. And last condition is it should have finite number of discontinuities. So let's consider one signal just like this. It is also periodic, right? The signal, but with small. There are lot of discontinuities over here. So this also doesn't satisfy Fourier series. Discontinuities in the sense there is a discontinuity over these points, right? Where whatever I'm marking over here. It is a point of discontinuities. It will be continuing infinitely over here. So, as there are infinite number of discontinuities, this also doesn't satisfy this Fourier series. So, like it has to, in order to get the Fourier series, it has to satisfy all these three conditions. Then only we can write it in the terms of Fourier series. So these three conditions are termed as Dirichlet's condition. And coming to the Gibbs phenomena. So I'll be considering a signal, rectangular signal. So it, uh, let's consider it minus half and plus half. So here the transition is happening, right? It minus half, and even at the plus half also transition is happening over here. So like what could be the value over here? It could be 0 or it could be 1. What is the answer over here? So Gibbs phenomena, if we represent this in the terms of uh, what to say, so this will be represented as if we there will be multiple frequencies involved over here, we'll be having lot of ripples over here. And if we make uh, uh, to infinity, I mean infinite number of frequencies, then we'll be having like this in order to get similar. So here the value will be half, like it is average of 2 points, 0 and 1. So we'll be getting half. So the value over minus half will be half. This is what Gibbs phenomena still. Am I clear till here? Hello. Continuity means for any value of, yeah, like discontinuity in the sense like where there are not differentiable also. I mean, like here it is. So if it is discontinuous means that point is not differentiable as well. Am I, did I clarify your doubt, Nanda? So like continuous signals will be like, I will be in this way. So if we draw a slope, we need to have value over here. But here at the point of discontinuous, if we take the mod function, it is continuous over here and over here. But when comes to this point, it could be
Ma'am,
assuming,
hello.
yeah,
Ma'am,
yeah, yeah.
screen is not visible.
Okay. Thank you. Well, is my screen clear?
Yes, ma'am.
Yes,
Can
ma'am.
anyone respond? Okay. For continuous signal, so continuous signal will take one signal like this. So whatever point we take over here, we have to have some value, one value, only one value over there. So these are the continuous signal. So if we consider the mod function, it is continuous except at 0, because we don't know what it, one side it is coming towards the 0, and one side it is coming, I mean one side it is negative and another side it is positive. We don't know what is happening over this discontinuity. So it is discontinuous, and discontinuous signals cannot be differentiated. This cannot be differentiable at that point. So these are the Dirichlet's condition, and if there is if it is discontinuous means it is not differentiable.
Okay, ma'am. Got it.
Like that's all for the day, what I wanted to discuss. And tomorrow will session will be taken by TA for further more for the problem solving. Any more doubts? You have in today's session? Yeah, revision session will be on Wednesday.